All right, so in this video lesson, we are going to be starting our next unit where we're going to be talking all about what are called complex numbers. Now, the reason that we're going to be talking about these is that they're going to be important for our next unit where we're going to talk about how to solve and graph quadratic functions. And so here's kind of the idea behind complex numbers, or sometimes referred to as imaginary numbers, is that they allow us to take square roots when there's a negative under the square root. Now, up until this point, you've probably been told that there is no way to take the square root of a negative number. And while that's somewhat true, there is no real number that works for, there is this new type of numbers that we're going to start to study today called complex numbers, where you actually can take the square root of a negative number. And so the reason why we are going to be using I is that these numbers are also sometimes referred to as imaginary numbers. Now, I want to be clear. Imaginary does not mean that they don't exist. In fact, they do exist. These are types of numbers. They actually do get used in the real world. Electricians use them. They get used a lot of time when you're studying electrical currents. There are some actual real world applications for these types of numbers. So rather than calling them imaginary, I will probably tend to refer to them as complex. However, the fact that they were once called imaginary numbers is the reason for the number I being used as the complex number, the most basic complex number. So here's what you need to know, is that I is actually going to be equal to the square root of -1. So anytime you want to take a square root with a negative number, you're going to end up with I as part of your answer. Now, if you think about what would happen if you squared both sides of your equation, take I and square it, you get I squared. Take the square root of -1 and square it, you're going to get rid of the square root sign, and you're going to end up with -1. So another important fact to remember is that I squared is equal to -1. So there is an actual number that when you square it, gives you a negative value. That's not going to be as important today as it will be in our next video's lesson, where we'll talk about multiplying complex numbers. So let's just start with some of the basics, remembering how to simplify square roots. So our first example, we're going to look at number 1. We've got the square root of 32. So remember, when you're simplifying square roots, you're looking for a perfect square that you can divide 32 by. The largest of which is 16. And if you take 16 multiplied by 2, you get 32. So when you're trying to simplify, you're looking for a perfect square, because then you should be able to simplify that. The square root of 16 is 4, and then the square root of 2 you'll leave next to it, and then there would be your answer for number 1. For number 2, same idea, square root of 28, you're looking for the largest perfect square you can divide it by. Turns out that the largest perfect square you can divide that by is 4. And if you take 4 multiplied by 7, you get 28. One of those square roots you can simplify. The square root of 4 is 2. Square root of 7 you'll leave next to it, and there would be your answer for number 2. All right. As for number 3, when you are trying to simplify the square root of a fraction, a couple different ways you can do that. First thing to check is, can you simplify it? In this case, no, you can't take 20 and divide by 9. So then your next step would be to go ahead and separate your square root by the numerator and denominator. So rewrite it as the square root of 20 over the square root of 9. One of those we can simplify right away. The square root of 9 is 3. The square root of 20, we're going to have to do a little bit of simplifying for. So let's think about a perfect square we can divide 20 by. The largest ends up being just the square root of 4. So we will rewrite the square root of 20 as the square root of 4 multiplied by the square root of 5 over 3. And again, one of those you'll be able to simplify. The square root of 4 is 2. The square root of 5 you'll leave alone. And then the 3 will stay in your denominator. So those, remember, are just kind of the basics of how to work with square roots and how to simplify things that you should have seen in geometry in a previous year. Now is where we're going to get to some new stuff. So on number 4, we've got this square root of -75. And so here's where you're actually going to get to see where complex numbers come into play. Let's first just think about this as a positive 75. And so if we were thinking about a positive 75, And thinking about a perfect square you can divide by, hopefully you're thinking about the square root of 25. Because if you take 25 multiplied by 3 is 75, and we can simplify the square root of 25. Now remember, it was a negative 75, so at the end of this, I'm going to put a negative 1. And if you multiply those together, 25 multiplied by 3 multiplied by negative 1, you do in fact get the negative 75 from the original problem. So now let's go ahead and simplify those. Square root of 25 is 5, square root of 3, we cannot simplify. And then remember, square root of negative 1, that's the new part for us today. The square root of negative 1 is I. And so our answer for number 4 is 5 square root of 3 multiplied by I. An alternative way to write that is to put the I between the 5 and the square root of 3. So some people will write this as 5I square root of 3. And the only reason to really do that would be to make sure that the I was not underneath your square root, because sometimes if you're sloppy, your square root sign can go a little too far, and then it looks like I is underneath the square root. But as long as you're careful, either one of these would be an okay answer. So let's take a look at another example. So on number 5, we've got the square root of negative 60. Again, let's just think about positive 60 and a perfect square we can divide it by. And it turns out that the largest is actually quite small, just the number 4. And if you take 4 multiplied by 15, that's going to give you 60. Now we need negative 60, so remember you're going to include the negative 1 at the end of that. So let's go ahead and simplify. Square root of 4 is 2. Square root of 15 we'll leave alone. And square root of negative 1 is I. All right, one last example. Let's see how this works with fractions. So, can't simplify negative 25 divided by 4, so let's just rewrite it as the square root of negative 25 over the square root of 4. All right, so first thing we can do, square root of 4, we can go straight to simplifying and saying 2. For square root of negative 25, this is probably kind of extending it a little far, but you could go ahead and rewrite that as the square root of 25 multiplied by the square root of negative 1, and then simplifying, square root of 25 is 5, square root of negative 1 is I, and 2 we'll leave alone. So our answer for number 6 would be 5I over 2. So really, here's the thing to think about. In order to kind of make simplifying a little bit easier, the only thing that really changes when you're simplifying a negative number is that you're going to have I as part of your final answer. So really, there isn't a need to put a square root of negative 1 when you're simplifying, so long as you remember to include I when you're finally done. So you could probably go straight from saying square root of negative 25 is 5I. You probably don't need to show that intermediate step unless you just like to do that. All right, so now, in general, complex numbers won't be quite as simple as numbers 4 through 6. There's actually typically going to be 2 parts. And so you're usually going to see a complex number written as A plus BI. And so those 2 parts have a particular name. The first part, A, is what's known as the real part. And it's known as the real part because notice that it's just a single number. There is no imaginary numbers attached to it. Whereas BI, and so that would be BI, not just the B, is what's known as the complex part or the imaginary part. So I'm going to put imaginary in parentheses. I think Big Ideas kind of uses those interchangeably. So yeah, complex or imaginary, either one of those would work. So let's talk about our first 2 operations. Let's talk about addition and subtraction. So when you are adding or subtracting complex numbers, it really is going to come down to combining like terms. Just remember to distribute the minus sign if it's a subtraction problem. All right, so this first one, I'm going to kind of show you what's going on. There's a lot of steps in this first one that we'll skip in the following problems, but I want to make sure it kind of makes sense what you're doing. So first thing that we're going to do is we're going to remove our parentheses. So 5 minus 7I plus negative 4 minus 3I. The next thing I'm going to do is use the commutative property to group up the real parts. So I'm going to group up 5 plus a negative 4, and then I'll rearrange my imaginary parts. So the minus 7I and minus 3i. Next thing I'm going to do is I'm going to use some parentheses to group those together. So the first group is going to be 5 plus negative 4, or 5 minus 4 if you'd rather write it that way, plus our second parentheses is going to be the imaginary parts, so negative 7i minus 3i. So we use the commutative property to rearrange the values, the associative property to regroup them, and now we can go ahead and simplify. 5 plus negative 4 is 1, plus negative 7 minus 3 is negative 10i, and then it would probably be best to just write that as 1 minus 10i. So notice that when you combine your like terms, that's really all you're doing. So I won't show all of these steps for each of these problems, but that's kind of what's going on as you're simplifying. Notice that when you add or subtract complex numbers, you also get a complex number as your final answer. All right, so let's take another look at this. In this next one, I'm going to be a little bit more careless, I guess. Not probably the best word, careless, but a little bit more relaxed as far as showing notation. Now, we do have to be careful because on part B, there is subtraction. So what I'm going to do is I'm going to go ahead and distribute that minus sign to that second parentheses. So the first parentheses will stay the same, 2 minus I, but then the second will become minus 5 and a plus 3i. So rather than kind of rearranging and grouping and all of that, I'm just going to go ahead and do that by combining like terms. 2 minus 5 is negative 3. I plus 3i is a positive 4i. So there would be our answer for example B. Let's take a look at one more example here with C. Again, we do have a subtraction sign, so let's go ahead and distribute that. First parentheses is going to stay the same, negative 4 minus I. Second parentheses is going to become a positive 2 and a minus 6i. And then we just have to combine like terms. Negative 4 plus 2 is negative 2. Negative I minus 6i is negative 7i. And there would be our final answer. All right, so that's it for this video. In the next video, we're going to look at how to multiply complex numbers. Until then, have a great rest of your day.